A stunt motorcyclist rides towards a ramp, and his velocity is given by this equation here, 10 root t, and which is in meters per second. To find out the motorcyclist's velocity after 1 second and after 2 seconds, we just substitute the time 1 into this equation. So that v1 is equal to 10 root 1. And that just makes it 10 meters per second. And now for after 2 seconds, we'll just insert 2 into here and work that out is equal to 10 root 2. And our answer is just going to be 10 root 2 to be exact. Or we may just say that it's 14.14, I believe, meters per second. And so to write the function, a displacement or distance for the distance traveled by the motorcyclist after t, we need to use integration because we know that st is equal to the integral of v velocity function dt. So inserting that function of the velocity in here as being 10 root t dt, and for easy integration we want to change it into a power form so that integrating the st will give us t to the 3 on 2 over 3 on 2 times 10. Plus c, and simply written it is just 20 over 3 t to the 3 on 2 plus c. And in this section we want to find the integral from 0 to 2 and interpret that answer. And so I thought just to illustrate, I'd take this out of Desmos, and this is going to be our velocity, and this is the time axis. So you notice that for time 2, the distance function will be illustrated by this particular area in here under that graph up to where the x-axis and time is equal to 2. So if I integrate it from 0 to 2 of 10t to the half, I will write down as 20 on 3 t 3 on 2 0 to 2. Before substituting, I want you just to look at this part over here because I'm going to rearrange it. So you might notice that I've went back from the power to the root over here because it'll be easy for me to substitute 2 into it. Okay, so it's 20 over 3 times 2 root 2, and then I need to take away the same thing, 20 over 3 times 0 root 0. Well, that whole thing is just going to turn out to be 0. And if you just calculate that, it'll be 18.9 meters. And so the motorcyclist travels 18.9 meters in 2 seconds. And in order to perform his stunt, the motorcyclist needs to be traveling at 20 meters per second. That is the velocity, or faster. So that is the minimum when he reaches the ramp. And the question is, how long will he take to reach a speed of 20 meters per second? If we're looking for this speed and we're looking at the time, we'll have to use this velocity or the speed equation. So as our velocity equation was 10 root t, and the velocity we're given is 20 meters per second, then we will substitute that in here and we'll say that's 20 equals to 10 root t. And we'll get a time of 4 seconds. So it'll take the motorcyclist 4 seconds to reach a speed of 20 meters per second. Now, a motorcyclist has started his approach 55 meters from the ramp. Has he given himself enough distance to reach the required speed? So we will need to know whether the distance when he travels from 0 to 4 seconds is enough. So we're going to calculate this distance from 0 to 4 and find out whether in that time he has had enough time to cover a distance of 55 meters. So he needs to cover that distance in 4 seconds. So we'll need to integrate that in 4 seconds. And we already found the integral above, so it was 20 over 3 t root t. And that's going to be from 0 to 4 seconds. We're going to substitute that, and that would be 20 on 3, 4 root 4, taking away, and I think you'll find out that that is going to be 0 here, because 0 root 0 is 0. Okay, so to finish off, we have 20 on 3, 4 times 2 is 8, which is 53 and a third meters. So yes, he will be able to make it to the ramp, because the ramp is 55 meters and he can do it in 53 minutes.